Hello little champs, welcome to Tinkerly TV. For more details, contact below website. Hello little champs, welcome to Tinkerly TV. For more details, contact below website. Hello little champs, welcome to Tinkerly TV. For more details, contact below website.
Hello everyone. So welcome to the Tinkerly's YouTube channel. Mr. Zodo is here and he is welcoming you all to the Tinkerly YouTube channel. So yes, what's new for you today? So hi, I'm Barbie and I'm back again. And the new that I have bought is an alarm system, which is an IoT device. So let me show you this alarm system, automatic alarm system, and the mechanism also, how this alarm system works. Let me just show you this project. So I will just start simulation. And yes, this is a buzzer. Let's start buzzing. So let me see the distance. The distance is below 100. If the distance is above 100, my buzzer stopped working. So this project is about the alarm system. Means if anyone is coming in the range without our permission, and if they come in the range and very close to the object and try to touch it and anything like that, my buzzer will start buzzing. So that is a project, that is a mechanism in my mind. If it is less than 100, you can make it less than 50 as well. But I have made it here less than 100. So if it is coming less than 100 and in the range, then my piezo will start buzzing. And it will start buzzing continuously. But if it is outside the range and below 100, it will not buzz because they have the range. The buzzer has a defined range. So just see. So now it stopped because the distance is about 100 centimeter. So this is how I made this project. So let's go back and what we have for today's journey. So roadmap to the today's journey is, the first stop is about alarm system. So what is the alarm system, where we can use it, how it works, that all we are going to see at the first stop. The second stop is about IoT. IoT as it's an automatic alarm system. So, but obvious, it is an IoT, Internet of Things. We'll just have a brief discussion about the IoT. Third stop is about electrical component that we have used for making this alarm system. And at the fourth stop, finally, we are going to design that alarm system. So let's start. So now we are at the first stop, that is an alarm system. So let me tell you the story about how I come to know about this alarm system. I just visited my friend's house and his home was fully secured system, means have the all security system. It's a smart home, we can say. Means you can see whatever is there, there will a buzzer. For everything they have a buzzer. Like if someone is the human body influence, if someone is trying to come in or in his house, the buzzer will come, buzz. They will come to know that someone without knowing them and in this particular range is trying to come. Even there is a smoke sensor, again the alarm will buzz. Gas leakage is there, if there is like, again this alarm will buzz. Then someone is trying to enter or without knowing and trying to steal something, again the buzzer. And this all buzzer they will come to know with the electronic mode. They will get a phone call or the message or the security system, the security person also come to know. So it was a whole we can say have a very smartphone. It's have a security system. So I learned it. I saw all that working of that, and I thought, why should I try this mechanism on the Tinkercad? a simple buzzer system. What will happen if someone is coming? So what electrical component I can use? That all I have studied and try to make this mechanism on the Tinkercad platform, which is a very virtual platform where we can try and see how the mechanism works. So this was all about how I come up with the project. So, but how this alarm system work? So first is the alarm system work is like motion is sensed. So if your window or your door is shut, and if someone is trying to come, the motions can be detected. We can place that sensor in our particular area, and the motion is detected. Once the motion is detected, the alarm countdown means the trigger starts and the alarm countdown begins. So now this alarm countdown begins with the control panel. The security system will be get alert. So like that sensor is connected to the control panel, and all the informations from the sensor, whichever they are detecting, the sensor will send back that signal, and the circuit will be broken, and what will happen, the alarm countdown will be triggered. So the alarm will, when the alarm countdown will trigger, the alarm will sound. The system is connected to an external bell or the siren or the piezo, and they will make a siren. They start making a sound. There is also an internal sounder that something event has happened. So the intruder will come to know, okay, the something has happened. That's why there is a siren, there is an alarm. After both, the thing has been, the person has means whatever the issue was there, if like someone has come, there has been detected, and if the thief has been you know we have just find out who was the thief and everything, the problem has solved out, the alarm is deactivated. So using the control panel, they will deactivate this. So like the smartphone can be used now for the remotely setting up and unsetting the alarms via apps. So as I've seen that my friend house, they have the alarm system, so his parents immediately come to know with the help of the smartphone that someone is trying to enter the house, or some leakage is there in the gas, and they, if they're not present at their home, but they can remotely access that, and they will inform the other, they can inform the police, and they can sort out the problem. Once the problem is solved, they can deactivate the alarm. So this is how the automatic alarm system can work, and this on this fourth step they can work. So where is the application, how we can use this alarm system? So there are various applications areas of this security system. Individual home as well as the apartments we can use. A gated communities where the people live together and have this common gate. Small, medium, and large retail store in a mall. If someone is trying to take the things without their permission, and they are just passing it, so they will put the sensor on their door. Okay, so they will put the sensor on their door, and someone is trying to take the thing without scanning. So they will immediately come to know, okay, this person has a thing which they have not scanned, means they have not done the bill. So automatically the alarm will buzz and the siren will come. So like this we can use it. Means bank, government agency, ATM center. We can use, yes, in a banks and everything, someone is trying to unlock the locker in an ATM, try to break the ATM machine, the alarm will buzz. Even in the restaurants and the hotels, for like example the smoke fire, or someone is entering in a premises without permission, like that we can use it. Even in the school examination cells, college, very good. Even in a temple, endowment, PCOs, internet centers, bakers, food courts, means almost in every field we can use the alarm system. Petrol bunks, large storage space, jewelry stores. So we can say the security systems according to their need, it can be applicable in almost every field, we can say. Just what was this working, just a motion is detected or any thing, whichever they wanted to detect, that will be detected, that will be triggered to the control panel, the alarm will buzz, and if everything is sorted, the alarm will deactivate. So on this 4-step, this all security system works. All whatever they want, they do it. So but obvious will require some sensors for that according to our need, like for like smoke sensor will require. So if someone is coming, the ultrasonic sensor will require, PIR sensor can work. So according to their need, this different sensors can be used, and there will be an alarm system. The alarm will buzz. So in this project, we are going to see what we are going to use, what is the electrical component that we are going to use, that we are going to see further. Now, second stop is IoT. As it's an automatic, it can be connected with the smartphones with the help of internet. The person is not there and can have an access to the alarm system. But obvious, it is an IoT system. Internet of Things. So Internet of Things is what? Any physical object embedded with some sensor, processing ability, some software, some coding and other technology, and connect and exchange data with the other devices and the system over the internet or any other facilities, we can say, but they can connect it with the internet, right? So they can exchange the data with the help of internet, like the smartphones, they can exchange the data over the internet. Now, this is what the Internet of Things. So device that we are making will require some sensors, a processing ability, that is a brain, and then some coding and the softwares, actuators. And yes, all this combined device will work on the internet and can be passed the information from one end to the another end through the mobile phone, through Wi-Fi, router, to the laptop, or like this, we can have the Internet of Things. The Internet of Things connecting the world. So we are all connected with the Internet of Things in every field, whether it is the smartphones, whether it is the industries, any emergencies, and we can say in a hospital, in any department, all are working with the Internet of Things, because it becomes easy to pass the information over the internet to the other things. Just we don't have to wait it. They are passing the information, signaling, and everything can be done on the internet. And so that when the other things get triggered, the systems can work automatically without human interventions. So very smooth functioning with the help of Internet of the Things. So this was all about the Internet of Things. Now, if we want to make that, so what are the electrical components we are going to use? That we will see. So I'm just making a simple alarm. So electrical component, I'm going to use a ultrasonic sensor, Arduino, and the Piezo Buzzer. So this I'm going to use. So let's see one by one what are all the electrical components. Yes, the first one is about Arduino. This Arduino is the brain. So in an IoT, in an electronical device, so this Arduino is acting as a brain. How our human brain works. Same, this Arduino works. Whatever the instructions we give, they do it. Our human brains works automatically. But in an Arduino, we have to give the instruction if this is happening, do this. So they will tell the actuators, the output to do that. For example, our human body, when they sense something, like if it touch the hot thing, so our skin has sense, this is a sensor, our skin is a sensor. So they will sense the thing, and they will the signal will, our brain will tell, please remove the hand immediately. So the movement of the hand, removing the hand, done immediately, because it was told by our brain. So in an IoT also, the sensor will sense, give signal to our brain, that is our Arduino, and the Arduino will give signal to your actuators, to your output, that what they have to perform it. So let me explain the pins of the Arduino. So This is the very important, that is a microcontroller at Mega. This is an IC. This is acting as a microcontroller, which is very important in the Arduino. Because of this only, the Arduino works. So Arduino has a digital and the analog pins, digital input output pins and analog input output pins. Depending upon the output, depending upon the variations, we have to connect our sensors and actuators on digital pin or the analog pin. Then we have the power LED. If we connect it with the power supply, this LED will glow. There is an power supply which we connect to the externally to a battery. So for that we have an external power supply. There is a USB jack which is connected to our laptop or to the, what we can say, to a computer. Then this is a transmitter and the receiver LED. It will blink according to the signal. This is the reset button and this is a test LED. So this is all about the Arduino. Now we'll move to the next, that is a ultrasonic sensor. So an ultrasonic sensor is an instrument that measures the distance. It will measure the distance of an object using ultrasonic sound waves. So what this do, ultrasonic sensor, they work on the ultrasonic sound waves. So sound waves require the medium to travel. So yes, the ultrasonic are also using the medium for traveling, but this ultrasonic sensor very high frequency which are not audible to the human being. So they worked on that frequency. They worked on that frequency and it is used to measure the distance. This is about a basic concept about the ultrasonic sensor. So how ultrasonic sensor work? This is an example of a bat. We know the bat, animal bat, they doesn't see, they doesn't have the eyes to look at the things. But when they travel, they follow the waves. Okay, that is they have the ultrasonic waves which is very higher to which cannot be audible to the human being, but this is audible to the bat. So what will happen if there is any object, they will send a signal to the object, and if it is if there is an object in between, the object will send back the signal to the bat, and then the bat will come to know, okay, there is an object in front, so he will use the different. Similarly, if someone object is coming, they will send the signal. If they are receiving the signal, they will use the other part. So like this, the bat is using the ultrasonic sound waves for their path, for motions, for how they wanted to go. So they use the ultrasonic sensor. So ultrasonic sound waves. So similarly, our ultrasonic sensor works on the same principle. If there is an object, there is a transmitter which send the signal. You can see this blue color one is sending the signal. If there is an object, they will have come to the signal and they will send back the signal, that is a sound waves, to the receiver. The receiver will connect the signal and they will measure the distance between the transmitter and the receiver. This is how our ultrasonic sensor, this is transmitter and the receivers work accordingly. So they will send a signal. If there is not an object, they will not receive it. So, okay, they will come to know there is no object in front of us. And the distance is also very important. So there is no object in front of that in particular distance. Like in this particular distance, there is no object in front of us. So there is not a problem. Now, if it is in the distance, in that particular range, whatever the range we decided, in that particular range, the object is there, the object will send back the signal, the receiver, and which will be collected by the receiver. So this whole process is working on this ultrasonic sound waves. The receiver and the transmitter and the receiver whole working on the ultrasonic sound waves. Now, so this ultrasonic sound waves, now when we are connected to our pins, to our Arduino, will be connected to the electricals. So here the sound energy is converted into the electrical energy. So this is how the ultrasonic comes. Now you will be like, what is it working in a sound energy? How they will have the electrical energy? So here they are converting whatever the sound waves they are sending, which is converting into the electrical energy. So now this is on a pure form of electrical energy. So this is a pulse. What is the pulse? The TTL pulse. They will get it, and which is converted into the direct current. Okay, so this TTL pulse will be there, which is a transistor pulse, which will connect directly. It is a direct current pulse, so it converted into the direct current plus, and it is related to the immunity. Doesn't affect the noise and anything. Related to noise immunity, we can say, doesn't affect with the noise. So after this will be converted into the electrical energy. So this is ultrasonic sensor works, how the transmitter and the receivers get the signals, and how the signals are converted into the electrical signals. That is all about. Now, what is the ultrasonic pins? How these are connected, how we can connect to your Arduino. So ultrasonic sensor has a 4 pins basically. There is a ground that is connected to the G and D of the Arduino. Echo pin, which is an output pin. And this is a trigger pin. There is an input pin. So from this input pin, they will transmitter for the ultrasonic. They will send the signals. And here in the echo pin, in the receiver pin, they will receive the signals. And this is now connected to the 5 volt. So this is the pin of the ultrasonic sensor. Now, what is the features of the ultrasonic sensor? This is supply voltage of 5 volt. Current. So this is what we have seen. This is VCC. This is a 5 volt. We have to connect to a 5 volt. So with the current which we get is a 15 milliampere. So modulation frequency is 40 hertz. So what is a modulation frequency? Is the encoding of informations, right? So whatever the information the waves are taking, there is an encoding informations in a carrier wave by changing its instantaneous frequency of the waves. So modulation frequency here is 40 hertz. So whatever is the encoding encryptions, the signal is taking is 40 hertz. So depending upon the output, it's 0 to 5 volts. So if they will detect an object, it will be 5 volts. If no object is detected, it will be 0. So output will be high when obstacle is detected. If any object, any people, anything is detected, then it will be high, else it will be low. So beam angle is maximum 15 degree. So the whatever the beam angle is, the distance it can be measured from 2 centimeter to 400 centimeter. So we have a lot of range, big range. So the distance minimum is 2 centimeter and maximum is 400 centimeter. So if the distance is too much, so the transmitter and taking back the receiver will be a time will be little bigger. Okay, because the signal is going at the 400 centimeter and coming back the signal, the time, the distance will be little bigger. So that's why we have said it depends upon the distance as well. Because sending the signal up to the object and coming back the signal, the distance back is very important in the ultrasonic sensor. Now accuracy is 0.3 centimeter, very good. And its communication is positive to 12, which means the transistor logic, that pulse is it's always a positive, and it is relative to immunity to noise. So it is has a good features the ultrasonic sensor has. Apart from we can use it in a what we say alarm system, we have a various application of ultrasonic sensor. It's used for proximity detections, liquid level sensing, whatever the how much the liquid has filled and everything. For that also the ultrasonic sensor is used. Obstacle detection, if someone obstacles coming in between. Ranging distance measurements, it's good for the distance measurement. Anti-collision system, countering or profiling. Collision means it's something is coming in between, for that. Also, we can use it at something come in between for that. They can make a sound or something. Countering or profiling, presence detections. If someone is present, like we are using the presence detection only. If someone is present in that particular range, we'll get a sound. Anti-intrusions, medical imaging. So we have a lot of applications of ultrasonic sensor. Now, our third, that is a piezo buzzer. So piezo buzzer is a type of electronic device that used to produce a tone, alarm, sound, buzzer. So this is a simple device which is used to create the sound. We can have the sound, we will get it. Now this is how the piezo buzzer constructions look like. This is upper holding, then here inside the piezo bender, and we have a wire connected to it. This is a PCB with drive circuit, and this is a lower. So like this, in between they have the wire connections and everything with the circuit. So inside it looks like this. Now, how the piezo buzzer works, right? The piezo buzzer gives the sound, right? So the piezo buzzer use a piezo crystals, a special material that changes the shape when a voltage is applied. So there is a coil. This is acting as a permanent magnet. So, and diaphragm. So whenever the current is passing, and this will, a special method change, it will change a shape. Okay, and there will be a magnet. Okay, so this magnet will have an electromagnetic effect and we're going to produce a sound. So in short, if we say the ultrasonic sensor was working on a sound waves, right? They convert it into the electrical energy. Now, after this, again, this electrical energy converted into the sound waves. So this is how they are converting. They were using, but these sound waves are not ultrasonic sound waves. This is an audible sound waves. So the sound waves converted into electrical energy. Again, the electrical energy is converted into the sound waves. So this is how our, excuse me, this is how our piezo works. Now the pins of the piezo, very simple. They have the two pins, negative terminal and the positive terminal. So the here in the, when we see the positive signs to indicate that this pin is a positive and the down one is a negative. So let's see how the piezo, a simple connections of the piezo, how the piezo will work, that we'll see. Simple. I'm taking the 5-volt battery and just rotating it, and we'll take a piezo. Right now, this is a positive and this is a negative. So it is like this, but we are able to know which is a positive and the negative. But in actual, where the plus sign is written, that is a positive. So this positive is connected to the positive of the battery, and the negative will connect to the negative. It's very simple, the piezo, and you can hear the sound. This is a sound. So this is very simple working of the what we say, the piezo working with the help of two pins. So yes, we have seen the three electrical components, that is Arduino, ultrasonic sensor, and the piezo. So these three electrical components I'm going to use to design my alarm system. So now we are at the fourth stop, how to design an alarm system, automatic alarm system. Yes. So now on which platform, let me tell you the mechanism, how we are going to do. This is the front facing. This is an ultrasonic, what we say, sensor, which gives the signal to your Arduino, that is microcontroller, and microcontroller will give the signal to your buzzer. This is a simple IoT. However, IoT device works on the same similar principle. This is working. So when they get the power supply, all three get the power supply. The give the signal to your microcontroller and the buzzer will buzz. So this is how we can do it. And this we can do it on the Tinkercad platforms. Tinkercad platforms allows anyone to virtually create and programming Arduino projects, excuse me, without the need for physical hardware. So this is how our Tinkercad on the Tinkercad platform we can make. So we'll start making our project. So you're on a circuit, then click on create new circuit. So let me just give you the brief introduction about our Tinkercad platform. So this is a space where we can do the designing of all the electrical components that and making a circuit. So here we can do the designing by taking various electrical components. Okay, so now the electrical components that we have to take is Arduino. See, we have taken the Arduino. So this is a digital input output pin, this is an analog pin, this is a power supply pin, this is a power LED, this is the external power supply, this is the USB, this is a transmitter and receiver LED, this is the reset button. So this is all about Arduino. Now the second that we have to take is the ultrasonic sensor. So yes, we have taken the ultrasonic sensor, the electrical component, and then we are going to take a piezo. See, so we have taken our 3 electrical component. Let's do the connections. So this is a, now in the pin, actually you have seen the trigger pin and the echo pin, but here it is acting as a both same. The trigger and the echo pin is the same, the signal pin. So let's say I'm connecting it to pin number 8. Let me connect this. Yes, it's got connected. You can see. Now, the second one is a 5 volt. The 5 volt, we have to connect to the 5 volt of the Arduino. So we'll connect to the 5 volt of the Arduino. This is a 5 volt. I can change the color, say, let's say to red, because it's a power. Now, the ground. Ground is connected to the GND. So we are going to connect it to the GND ground. And we'll make it as a black color wire. So ultrasonic sensor connections we have done. If anyone is sending the signal, means anything is happening, the detection has been done, or according to the range, this after doing this, this will give signal to your brain. The trigger pin and the echo pin is acting as the same. So this here will give the signal to the Arduino. So now after that, whatever the instructions which is written inside the Arduino via programming or the coding, then will give a signal to your piezo, which will be acting as the actuators. So now do the connection. So here positive, we are not going to connect 5 volt, because if we connect it to 5 volt, directly the piezo will start buzzing. It will not stop it. Now for that, if we want, we have to connect it to the pin number. So any pin number we can take, let's say pin number 7. Color yellow, and the negative will connect to the ground. So as it is, so we don't require so much of, we are not using breadboards, so we can just connect with the help of jumper wire. It becomes easy. So this is a very simple connections, right, of this. Now we'll do the coding. So here it is a block coding. So this time I'm using the coding We are not going to use this code. We are going to create our own code, but this time I'm going to do the coding on a text. So we are going to do that on a text editor. The block coding we are not going to use. So we have to be very precise when we are doing the text coding, because a text coding is like a language, right? So the instructions that we are giving, it's in a proper syntax, like we use for the proper particular language, how to give the full stop and how to write the codes and everything. So for this programming language, coding language, also we have to be very precise when we write the coding. So already we got the two functions like void setup and the void loop. So in this, we are going to do the coding. In a setup, we are going to tell what will be the pin modes. And in a loop, we'll do the actual coding. So first, I will write that about the two pins that we have connected to our Arduino, about that pin. So I will say the const, and it is an integer. Let's say this is a ping. So I will giving the name as ping pin equal to on which pin number I have connected. I have connected on pin number 8. So I will use ping pin 8. Right? Now I am using the buzzer pin. So it will be constant. It is not going to change. That's why we are using const. That is a constant. Int means the integer. This is an integer variable numbers. That is not a decimal or anything. It is an integer, particular number. So that's why we are using int. Int is for integer. So int buzzer pin equal to 7. So we have connected this two pins on this particular pin number, and instead of using the pin number, we are going to use this variable ping pin and buzzer pin. We can give the name any whatever, like pp, bp, whatever we feel like. This is the variable I have used, ping pin and the buzzer pin, that we are going to use. Now in a setup, I'm going to write what is the pin's mode is. So now I will write pin mode, that is a buzzer pin, comma, output. It is acting as an output. So I'm just telling that a buzzer pin is acting as output. Now your ping is acting both, because the transmitter and the receiver, it is input and the output. It is an output pin. Now we'll write serial begin. Serial dot begin in bracket 9600. So serial begin means we are telling the Arduino to be prepared. You are going to get some instruction signals. Then you be prepared full of boot. So that is a serial begin. Now we are on a loop. So in a loop, what we are going to write the actual coding. So we have seen the ultrasonic sensor uses, means how the ultrasonic sensor works. So they send the signal, they take the signal, and the distance is very important. So what is the distance between the ultrasonic sensor and the object? That is also important. So we have to calculate the distance, and that pulsing also we have to calculate. So for that, I'm using long. Long is again a type of what kind of variables you want to declare. That is a long. So duration and centimeter is my two variables. So I'm giving the semicolon. So long, duration, and centimeter. Now I'm writing the pin mode. First, the pin mode of the ultrasonic sensor. So the pin mode, comma, that is a ping pin first output. It is acting as a first output. So I will write PUT. We have to be very precise when we are writing PUT, that is output. Now this is pin mode initially is at output. Now what will happen? We are going to write the digital write. Digital write means this. We are connected to the digital pin, so we are writing the digital write output. So digital write in bracket pin, comma, low. First we are telling to be low. Then we are making them delay of 1 second. So for that we have to write 1000. After that, we have told that pin should be what we say, it is low. Now after 1 second, it will be high. So I'm writing digital write, this D is small, digital write pin, comma, high. Then again, I'm telling to wait for 1 second, delay of 1000. And then I'm again making it as a low. So digital write pin, comma, low. Now this particular, after this particular line of code, what I'm doing, I'm telling, so just make this, and for that, I'm just making it easier. So what I'm telling now my pin mode is input. Okay, so P will be small, pin mode will be now input. The pin will be input. This now acting as an input. So I'm just writing input, semicolon. Now this is acting as an input pin. So whenever the pulse in that we are going to get it, that whenever the pulsation is high, that value will be stored in our duration variable. So what I'm writing, duration equal to pulse in of pin, comma, high. When it is high, that value is coming in duration. Now this pulse in whatever the duration, the receiving and the transmitting duration, with the help of that duration, we have to calculate the distance. They have sent the signal, they received the signal, what was the duration? So in the basis of the duration, we have to calculate the distance in a centimeter. So that will come in the variable centimeter. So if the duration is too long, means once they send the signal and after receiving, they are getting the signal at a duration will be too much, then the distance will also be too much. If the sending signal and the receiving signal duration is low, the distance is also low. So that duration, we have to convert it into the distance. For that, we are using centimeter. And that distance value will store in a centimeter. The whatever the receiving and the transmitting is coming the duration. Now this duration will use to calculate the distance, and this distance will be stored in the variable centimeter. So centimeter is equals to micro second to centimeters. So now we are converting our microseconds to centimeter. That value will be coming in the duration, right? That value, this value, whatever the pulse in, that value, which value comes in the duration, now we are converting into the centimeter. So we have now converted into the centimeter. We got the distance. Now for my programming, if the distance is like, if I'm using the if else condition, if centimeter is less than 100. So I find it is 100 centimeters person is so near, means I have a range, like in a jewelry shop, I have a range. My diamond is just kept in a particular range. So if it is less than 100 centimeter, means they're trying to break the block. The distance is centimeter, just 100 centimeter. The diamond and the block, which is kept in a glass block, is just 100 centimeter. If it is less than 100, means someone is trying to break the block and trying to enter it. So immediately they will give the siren sound. They will immediately give the siren. Yes, someone is trying to touch it. Now the distance of the door and something like a window, if it is like very near, the person is standing, and if someone is trying to enter it and it is less than 100 centimeters, someone is trying to enter through the window, so they will immediately get the sound. So like this, we can have an alarm system. So if centimeter is less than 100, open the curly bracket, close the curly bracket. In between, we have to write the code. If centimeter is less than 100, we will write digital write that buzzer pin. Our buzzer pin now will be high because it is less than 100 centimeter. See, now for the else, again open the curly bracket, close the curly bracket, and in between, if it is greater than that, we'll write digital write buzzer pin comma low. So it will be quite. If it is greater than 100, yes, the person is standing below and just he's watching the diamond. So not a problem. The buzzer will be, as soon as the dead distance has been crossed, it will make a sound. So that was the mechanism. So yes, we have done, and I'm just making the delay of 1 second. Okay, now we have written the coding. Now after this, what is microseconds to centimeter, right? So that functions coding we have to write here. So that is a long, because we have used the long, which is bigger and in a decimal. So that is coming in that duration, right? We have taken the variable long. So whatever the long, just let me write, I will explain you this. Microseconds to centimeter, microseconds to centimeter. Now it will send long microseconds, right? It will send long microseconds. Now in open curly bracket, close the curly bracket. In between, we have to write return microseconds space slash 29 slash space 2 semicolon. So what we are telling, this microseconds to centimeter, they are returning some value. Okay, so that value will be long. Okay, the value will be long. That's why we have written the duration. That will be the long value. So whatever they are sending, it's coming in a duration, right? So this is how the function will work. Let's check the start simulation. If any error is there, we'll get the error. So initializing, yes. Microseconds to centimeter. To centimeter. And here what we have used, microseconds to centimeters. So instead of centimeters, we'll use centimeters or centimeters. Here we'll use it. So becomes same. Let's check. Okay, that was an error. You can check it. The error means if whatever you can find out the error, immediately you will come to know if something has gone wrong. We'll find it out. So microseconds to centimeter. So now we'll check it. We'll just put it little down. See, the distance is about 113 centimeter. So it is not buzzing. As soon as start making the sound. it is outside. It's not. So if it is not in a range, the buzzer is not buzzing. So because we have given the delay of 1 second, that's why after 1 second it is making a sound. If we don't write that, it will not make a sound. See. Stopped. Now again we'll bring back. So it is converted into inches and centimeters. So this is how we can make our alarm system. Now, if I'm writing less than 50 centimeter, stop simulation. And if I'm writing just 50 and start, just little down. So you can see it is 100. Earlier it was buzzing a sound below 100. Now it is not. Now it will start buzzing because we have written the distance. So very distance, if we are writing, the buzzer will start buzzing. So like this system, we can use it in a mall. If someone is trying to take the things and going out beyond this range, the buzzer will buzz it. Right? And in a jewelry shop, in a bank system, yes, the person has just crossed the limit and come in the area where they should not be. In an examination center where the books and everything are kept, they are just come in the area which is not permittable. They will get the siren. Or if we kept something confidential file or something, so person has entered the room without the permission and trying to the buzzer will. So this is how our alarm system will work. So this is how the mechanism of the alarm system. Now we have seen, or go back, what we have taken away from the journey. So we have seen what is the alarm system, where we can use, how it is an IoT device, and what are the electrical component that we have used, like ultrasonic sensor, buzzer, piezo, and we have seen their function, like piezo, how the piezo works, how the ultrasonic sensor work with the transmitter and the receivers, how like it's same like the bat functioning, the animal bat functioning, the ultrasonics works on the same way using the ultrasonic sound. And we have also seen that how they are converting, like first the ultrasonic sound waves, that is a sound energy is converted into the electrical energy. Again, the electrical energy is converted into the sound energy. So how the mechanism is working. And at the fourth stop, we have seen how we can design, how we have made this ultrasonic alarm system with the help of ultrasonic sensor and the piezo. And this was all about today's journey, the automatic alarm system. So here now Barbie signing off. Take care. Stay tuned. Bye-bye.
Hello. I am back again. Thanks for watching Tinkerly TV. Subscribe us. Contact to below site for more details and queries. Hello. I am back again. Thanks for watching Tinkerly TV. Subscribe us. Contact to below site for more details and queries. Hello. I am back again. Thanks for watching Tinkerly TV. Subscribe us. Contact to below site for more details and queries.